Good morning, folks. If you're not interested in segment routing, now is a good time to leave the room. Adrian, thanks. If you are interested, it might be a good time to leave the room still, but you know, it's fine. So welcome to Spring IETF 105. We have a fairly packed agenda as usual, so we'll get right started. If you haven't seen the note well, here is the note well. It's Wednesday, I expect you've already seen it. We need a minute taker and a Java scribe, please. Do we have any volunteers? The minutes we can do on Etherpad as usual. Any volunteers for minute taker? Please.
At least Java.
So okay, that's not great. We can lock here if you'd like. Somebody to watch Java? Adrian, thank you very much indeed. Stuart suggests that we need a working group secretary. Volunteers for that, I'm not going to block on right now. So the document status, and thanks, PK. The document status since last time, we adopted SRv6 network programming. I think we're pretty much there with adopting the SFC drafts that we discussed last time too. And the RFC editor is very close to publishing this large cluster of documents that we've had all in sort of interdependencies between their references. So that's the MPLS base, the LDP interop, a bunch of MPLS documents that are SR related, some PC ones, and then the IGP extensions. So this represents a pretty good step forward once this lot gets published. We were at the stage of debating what the order of the RFC numbers should be. So I'm thinking at this point we're pretty much done with these. But this is good because it also closes off some of our milestones. So this is the set of milestones that when we eventually recharted last year, we kind of reached the SR MPLS document we've sent to ISG. That's great. We had this milestone for MPLS Anycast. This document seems fairly dead, and so I think we probably should conclude whether we actually need the document or not, and if we do, then it needs to be brought back to life. If not, we should remove this milestone. The Yang config model, we're pretty much there with. I think the authors have now addressed all outstanding comments on it, so we just need to progress it through the working group process. Then we have a set of things where we have documents, and we just need to figure out whether there's extra work required. SRT policy, there's been relatively limited review of this doc. I added some comments, but it would be good for folks to look through this because it's a document that most of the other IGP, the BGP extensions, the PC extensions are dependent on. So it would be good to get a detailed technical review on this from more of the working group. For SR, MPLS, OAM, and performance management, we progressed some of the LSP ping work in MPLS. There's other parts that Rakesh is presenting on today. I think what would be useful is to figure out as a working group whether we have anything outstanding there. Is there anything that we need to specify? For performance management, Bruno and I are still kind of discussing and would welcome input on where we should progress this work. Should it be done in MPLS, IPPM, or should we do it here in Spring? SRv6 network programming, Cameron's going to give an update on today. And the SR policy Yang model, I don't think we have a document for this at this point.
Governance and Cisco systems, yes, we do have a document that is submitted. A draft has expired, it was renamed and has been submitted. We asked for a slot, we'll probably get next time.
Okay. Thanks. That's great. And then the stateless service chaining work, we've got the 2 drafts that we agreed to adopt last time. So we're progressing through some of these. I think it would be good to kind of focus our work on making sure that these milestones get completed. We have quite a lot of proposals for new work where not necessarily a bunch of progress on some of these things. This is something Bruno and I were discussing yesterday. We'd like more technical review of documents in the working group. I think we're going, we have a number of drafts where we kind of adopt them and then, or they come to the working group and we don't necessarily have detailed technical review on them. So what we're proposing to do is to have 2 technical review, a gate that says 2 technical reviews of document must be done before we consider working group adoption and the working group last call. So what we would say there is like, if you're an author of a document that you would like to be adopted by a working group, please find some folks that are also interested in your working area and let's make sure that we get some review as to whether this looks like the right thing. I think we want to make sure that we surface technical disagreement earlier in the process rather than necessarily getting to the stage where we're late in the process and then folks disagree technically on what the right approach is, as we're seeing with some work today. So any comments on this as a particular, if we introduce this as a requirement in Spring, is there a strong disagreement to this or any disagreement to this or agreement? Okay, silence is consensus, so. So this is the, silence is not consensus, it turns out.
AC Linda, Cisco Systems, you can request, the chairs can request routing directorate reviews, both at both points.
Absolutely. I think one of the challenges is the trying to make sure that the documents get iterated on in the working group. So the director, I think, is great for giving us that external perspective, but it doesn't necessarily, I don't think we can sign those folks up for helping with progressing the documents. So this is also to try and give us a wider group of folks that are able to help progress work through the working group. But thanks, AC. So this is the agenda. We, as usual, had a lot of requests. Well, actually, not as usual. This was, we had many more requests for this meeting than we had for the previous one. So Bruno and I went back and looked. We have about 5 hours of requests for 2 hours of meeting time. This time, it makes our job particularly difficult, especially if there's been no discussion of the draft and it's a 0-0. We end up then inevitably having to add things, to drop things and prioritize the work. Please try and make sure your draft is discussed on the mailing list. Please try and make sure that you've garnered some input. It's the earlier the better you submit the draft, I think. So if you haven't got a slot on the agenda, please introduce your work on the mailing list. Let's have a discussion. Just as a transparency thing, the way that we prioritize the agenda is that we first look at whether we have discussions for things that have already been adopted by the working group, and then by things that have interest in the working group, which is usually indicated by what happens on the mailing list. If your draft has not been discussed on the mailing list and it's not a working group item, you should probably expect that it is in the bunch of things that we're not clear that we have to make a prioritization decision about. Okay, so unless there's any last minute agenda bashing, then I think we're ready to kick off.
Robin from Huawei, I have a question. So why not we arrange another session for Spring Working Group?
It's not clear that we could have added another session, we could have added 2 more sessions, but it's not clear it's actually a good use of time, right? So if the reason to have an additional session is just to introduce a bunch of 0-0 drafts that we haven't got any kind of clear consensus that are interesting to the working group, then what's the bound? So I actually, in my opinion, it's better for us to have less time and prioritize work such that we make forward progress on it rather than we have a bunch of drafts in the working group which don't go anywhere.
Hi, I'm Bob Hinden. Just if it's helpful, what we do in 6-man for drafts that have not had discussion or new, we give them 5 minutes at the end. No, you know, basically title slide, 3 content slides, no discussion. It's just a way of introducing the work. And that's how we manage this.
We were proposing to steal your process with credit.
Good.
Okay, who's first? Cameron.
It's working like this.
Yes.
Say next slide and I'll put
that. Okay, you will do that. Okay. Hey, hello everyone. My name is Kamran. I'm going to give a quick and short update on SR-Risk's network programming draft. List of main authors and lots of contributors. I think they got chopped in this change, but you can look at the draft. So we had presented this draft last time in Montreal IETF 102. So this is really an update since then. Next slide, please. So after Montreal 102, right, we have a network programming individual draft version 7. Based on the feedback from working group and chairs, this was split into 2 documents. We took the illustration out of the document and submitted a 00 version draft for the illustration. And after that, the remaining part of the draft basically was adopted as a working group document during last IETF. So we resubmitted it as a draft IETF 00 after Prague. Next slide. Since Prague, after submitting as an IETF working document, we updated this document furthermore. The key changes to the document version 00 IETF to version 01 are basically we added representation of the SR-V6 locator broken into block, operator block, and a network ID part. This was added as a request come from control plane protocol. I think it was presented in LSR working group in ISIS city structure TLV, as well as BEST working group yesterday for SR-V6 services draft, which also uses city structure TLV. So this B:(n) representation of the locator was done based on control plane request. We also added a normative reference to SRH insertion draft. That was to take care of a comment that came as a last IETF. We also clarified the use of no next header for IPv6, which is value 59. I have further slides to discuss this a little bit more in detail, but we changed the text to clarify a little bit more. And also we updated the registration procedures for our endpoint registry in IANA. It was originally specified as IETF review, but since other non-IETF bodies like 3GPP, they can also request allocation of or request some endpoint behaviors. So I think based on that, we changed our registration procedures from IETF review to specification required as per RFC 5226 guidelines. And we also made some minor editorial updates to our version 00. Next slide, please. So that is version 01 that stands today. What we plan to address in our next revision or so is basically align our network programming draft with segment routing header draft, which is in ISG right now in 6-man. It has updated pseudocodes and behaviors. So we plan to update our network programming to align with those changes. That means it will be a large editorial changes to update all our pseudocode to make sure they align with the SRH draft after it has gone through further ISG review. So that is what's coming in our next revision, and there are future items that we can discuss later. Next slide, please. Okay, so there are the two main open issues. One was the definition of effective next header field. I think this will be no issue once we have already aligned our draft with SRH draft in the next revision or so. Then the definition of ENH will really be non-issue because our pseudocode will be aligned with SRH. So I think that issue will be solved. It will not be actually no issue going forward. The issue number 2 is, I think, the main issue that we want to bring to the working group is the use of next header 59, which is no next header for IPv6. So our reasoning for using this in our original proposal and our original specification is that the SID itself basically defines type of packet processing and what is underneath the IPv6 outer header or SRH after SRH headers. So the SID basically provides the context of the what you need to process after decapsulating the IPv6 and the extension headers. And basically, no next header for IPv6 identifies there's no further IP header to process in the packet. It does not necessarily mean there's an Ethernet header underneath, and I'll talk about that a little bit later. So there was a lot of discussion on the mailing list, both in a Spring and 6-man working group, without any clear consensus. There were a few suggestions that we have listed here. There was proposal to use next header 97, which is an Ethernet, with Ether IP specification RFC 3378. But that brings some compliance issues, and then requires an extra Ether IP header to be added between IPv6 header and L2 frame on encapsulation side. So there's that it has this cons. There was a proposal to allocate a new protocol value out of IANA protocol, Internet Protocol Registry, to specify something like next header equal to Ethernet. There's again no clear consensus on that. There was also discussion to basically redefine the meaning of 59, and the last but not least is to keep using the current use, which is 59. So these were all 3 or 4 proposals that went back and forth on the mailing list with no clear consensus. Next slide, please. So additionally, I think one thing we'd like to highlight that most of the solutions that were provided, do not cater to basically Ethernet frame or unstructured PDUs, because in cases of 3GP specification under IPv6 encapsulation, IPv6 outer header, you can have unstructured PDUs, which do not necessarily have to be Ethernet frames. So they also are using value 59. So even if you even define a new type or whatnot, I think one specification cannot handle both cases. So that is one thing that basically also to keep in mind, that we not only have to worry about Ethernet frame under IPv6 header, but maybe unstructured PDUs as well, 3GPP and maybe some other feature work going forward. And since we already have a 59 which says no next header, defining another thing that says the same thing, really, I think doesn't seem very reasonable to us. So at this point in time, I think between authors, we recommend to keep using 59, and as well, because there are already implementation in progress and probably completed, which are already using 59 with the semantic in mind. Yeah. So says next slide, please, Rob.
Yeah, I strongly disagree. You should not be using this. No next header in IPv6 means no next header, period. Doesn't mean something else. You should do something differently. I'm fine if you get a new allocation, but this should not break current IPv6 usage, and I think this will. I mean, as we said this quite clearly on the mailing list. So I disagree with what you just said.
Okay.
Just to reinforce that, I do not think the working group can adopt this document with this usage of 59. It is a violation of existing RFCs, and you can pretend the RFCs mean something else. They don't. This is very clear. There are multiple possible alternatives, or you can find another alternative. I don't care. but you can't just hijack an existing code point and change its meaning.
Tom Herbert. So I think there's a similar issue with extension header insertion. So the draft does update the reference, but it references the document that we did describe on 6-man briefly, but the conclusion, maybe the conclusion was you really can't insert extension headers into packets without encapsulation.
Okay, point taken.
Lorenzo Colletti. I wanted to I wanted us all to think about, how much IPv6 address space this paradigm will need. I read through the draft and it says, well, the examples here are we allocate a /32 for every router, but we don't say how much we need. So a 32 per router is very expensive, right? Because if you want to have some sort of reasonable number of routers, you'll easily end up saying, well, with some wastage, you end up requiring a large address block just for this. Now, I think saying the exact amount of, the draft says basically the exact amount of space is unspecified, depends on whoever deploys this. I think given the excessively large amount of space used in the examples, I think there are two problems. First of all, we need to give some examples that won't cause operators to use very large amounts of space. And second, I think the draft needs to have a credible discussion on how much address space is actually needed for a useful deployment of this model. Because if it turns out that you need a /16 to make any of the useful stuff in this document work, then it's not going to fly unless we get IANA to allocate a /8 for this. Right? So if on the other hand, it's fine to say, well, you only need a /64 for the whole network, then there's no concern. My point is we can't say this is just a parameter that we're just going to move it left and right, because if we move it too far to the left, it means that basically we're taking a large chunk of the internet and throwing it away. Okay?
Are you commenting on microsegment? Microsegment?
No. The draft that's on the screen. Right, the network programming draft, it assigns, the example assigns a /32 for every router loopbacks, right?
Yes, it does.
No.
I just read it.
In
right.
example you're saying?
I just read it right now. I'll go get the text.
Which?
Network
Just
program.
for Darren Dukes from Cisco Systems, just for clarification, I think he's referring to the examples. So if you were to use a 2001 DB8, it's a /32. The examples are given for brevity and the number of characters it takes.
This is just examples.
They're just examples. But I think maybe he had another point where he asked for a credible discussion on address space.
Sure, that's a separate point, and we can definitely.
Let me put it this way. If your example is a /32 per every router, A, people are likely to follow it, and that's wasteful. And B, somebody reading it might think that you can't do anything unless the actual amount of address space is on that order of space. And that is kind of wasteful, and we need to think carefully about it if that needs to come from global space.
Sure, we can clarify that. Thanks.
Yeah, Janenko, I like to second what Lawrence is saying, because I read the draft, and initially, to be honest, I was confused, because I was thinking the draft might be confusing IPv4 and IPv6 by assigning /32 per loopback. I was thinking it's a typo initially, right? But the draft keeps saying that in the example, and it's not example net. It's actually A:1 /32 and then B:1 /32. So it looks like you're clearly providing an example of /32 without any real justification. And people tend to follow RFC. So I do believe we need to have some discussion on address space, which is actually required, why it's required, and where it's coming from.
Sure.
I'm not, otherwise I need to go and start working on IPv12 deployment scenario.
Sure. Those are mostly for readability convention, but definitely can take this comment and update.
Hi, Andrew Alston here. I just wanted to second what Jen and Lorenzo have said, but I also wanted to raise the point here that we're talking about address space here per router. But if you look at what network programming does, it talks about end points, right down at the end.
Mm-hmm.
That makes this far worse than a 32 per router, because this then becomes per Docker container. I've got to be able to steer and program all the way to the end. And in the context of the examples, even if I was using a 48 there, the amount of space that I'd be burning would be absolutely, so this is something we really, really need to look at.
Okay. So can you send this also on the mailing list and we can continue there? But I want to get back to ENH, next header discussion.
So Stuart Bryan, I want to talk about next header.
Okay.
So I was looking at the registry. There are about 100 of these things for the entire life of the internet, which we hope is a very long time. It seems to me that if you do anything, you should put an indirect operator in there, because I can see a whole load of pseudo wires going over here as well as Ethernet. I can see a whole load of programs going over. I can see many constructs. So if you go for a new type, you really should use that to introduce a shim, which you can then play with as much as you like.
Thank you.
Ron Bonica, Juniper Networks. I'd also like to talk about the effective next header. 2 comments. First, RFC 8200 calls the effective next header the upper layer header. Might as well use the same term as opposed to redefining a new one. Second, there are about 9 SIDs that require access to the ENH to process. I'm thinking of SIDs like end DT4 and DT6. When the effective next header follows the SRH, it's easy to know what the effective next header is. In some cases, when the effective next header does not follow the SRH, the only way to know what the effective next header is to chase the chain all the way to the end and then go back and process the SID. In some cases, where there's an ESP between the SRH and the effective next header, you have to do a de-encryption operation to get there. It might be a better idea, rather than putting those SIDs in a routing header, to put them in a destination options header, so the effective next header will actually be the next header, and it's easier to process. There's no reason to put a destination option in a routing header.
Okay, so Ron, you already mentioned that a segment routing header draft is getting updated, and then ENH will not be a problem in our next revision, but I'll let Darren comment more from SRH side.
Yeah, Darren Duke, Cisco Systems. The pseudocode in the SR header drafts walks through how an SRH is processed and any subsequent headers are processed. Like Cameron said, that pseudocode style and mechanics needs to be adopted by the network programming guide. And when that does, I think your questions, well, they're answered simply because the next headers get processed in order.
Well, still, to process the SID, you need to know what the effective next header is, which means you need to look well beyond the routing header to know what to process it.
Again, in the SR header drafts, we describe how that upper layer header is processed, and when that same pseudocode gets used in network programming, then this question will be moot. It won't exist because it will describe how that happens.
Yes, the complexity simply goes away if you put it in a destination option header.
Well, okay, you introduce many extra things if you put something in a destination option header, TLV parsing, blah, blah, blah. But, like we said, the pseudocode will solve that.
Yeah. And I think we'll take this further to mailing list. But for NH59, how do you recommend we take it to mailing list and continue from there?
So there is a suggestion to ask for a new header, next header. So
author can go and
we could try that.
Okay. So I think author can meet and then I'll update on the mailing list. Right. Okay. Right. Thank you.
Anyone who hasn't signed the blue sheet?
Way back there.
So I want to thank the chairs for letting me speak here because I did, oh, thank you. I did submit this draft late. I have to say a couple of things. One is I'm trying to be helpful. You may or may not believe that. And the second is this is just a proposal because the idea of managing, especially global SIDS, manually or through funky ways didn't appeal to me. And then because for the ring thing, I was going to introduce more of them, I decided we need to just tackle the problem. The second thing is I just subscribed to the spring mailing list. I think I'm going to unsubscribe right now. I don't know what kind of these discussions about ENH and stuff. It's like, I don't know. Actually, I should confess. I don't know DHCP. I don't know IPv6. And I know very little Spring. But we'll manage. Okay, so the problem statement is basically you need SIDS to be unique. There are certain types of SIDS that you want to be unique. Unique in a certain domain, maybe in an IGP area, maybe in an AS. And so you definitely don't want to allocate the same SID to two different routers unless you're doing Anycast, which is a special case. And ideally, as a router that restarts for some reason should get back the same SID. Now, if you do it by configuration, you will. But if you use other means, you need to kind of try to, it's not a must, but it's a very, very should, if you can do a very should. So you can do this with manual management, but there are problems. And then as the number of such types of SIDs goes up and the number per router goes up, the manual approach doesn't look very good. So, so this is sort of a poor man's sketch of how this would work. It was a nice, animation thing, but this is fine. It's pretty much what you would expect. Is a couple of things I want to highlight. Initially, all the routers are provisioned with sRGBs, which is the same as today, and potentially a DHCP server address, although some of our discussions are towards putting that in ISIS or something because, got everything else in ISIS, might as well put that in. Because we're going to use unicast DHCP for this. So then any router that's configured to do node SIDs or ring SIDs or whatever will make a unicast DHCP request for a SID of whatever type it wants. The DHCP server basically, it doesn't really care about any of the semantics of this. All it needs to know is, did this router already ask for this SID, in which case it should give it back. If it hasn't, then it makes a binding, and then it gives the SID. So it just thinks of this as a block. And, you allocate a SID, you say that that SID has been allocated to this router, and then since it's DHCP, you have release time, but you can keep that to be pretty high. And then you reply that SID and router or loopback address binding back to the router. And now the router can advertise it into IGP or whatever it wants to advertise it. So essentially, this DHCP loop it replaces a configuration step. And then the one thing that you have to do if you're using DHCP is before the lease expires, you want to renew your lease. And if the router restarts, it needs to, the DHCP server should make sure it gets back the same SID. So there's a timer for the lease, and then there's another timer for how long you want to remember the router to SID binding, which could be much longer than the lease time, or it could be the same. Again, I don't know DHCP. But the point is, you do want to keep that sticky. You do need a backdoor in case that router is never going to come back or whatever. But you could just have that binding. Unless you're really tight on your SID block, you could just have that binding be for a really long time. So typically we'd use this for node SIDs, Anycast SIDs, ring SIDs, which if I have time, I'll talk about. It could also be used for all these other compressed SIDs that we're now at least having a discussion about. The second part of my talk is I'm sneaking through the back door. The use of SIDs in rings. Before I go there, though, I do want people to comment on the use of DHCP for this. I see Adrian getting itchy. And I mean, like I said, this is trying to be helpful. So if you think that this is not a good use of DHCP, I should also say that I know the DHCP RFC, one of them says, don't use this on routers. So of course I want to use it on a router. But that said, if you have any reason, technical reason, why this would not be a good thing, or if you have alternatives, I think this should be discussed. But trying to get anything that you can make not manual is a good thing, I think. So, Adrian.
Hi, this is from Jabba. Oh, I've now got two questions in Jabba. First one is, how does this work when you need two SIDs for a device?
It's a very good question. You want two SIDs for the same prefix? Yeah, it's no. Okay. So it is a good question. We've had this discussion, but not enough, and I don't know enough DHCP. But I do specify that in the draft that if you were requesting a SID, a ring SIDs, they come in pairs. So you get a clockwise and an anti-clockwise. So I just want DHCP to do that. Now, can it? I don't know, but it should be able to. For other cases, if you want two SIDs, but you have only one prefix, we'd probably have to do an extension for that.
Right. So maybe,
it's a good question.
Maybe the person who's raised this point can contact you
sure.
on an off list because you're not on the list.
No, I'm on the list.
Oh, I thought
I might be on the list at the end of the session, and then no,
right.
I'll stay.
And the second one from Robert Razouk is, why not use Lisp mapping plane instead of DHCP? I'm only the messenger, okay?
To my limited knowledge of DHCP, it's a very good tool for saying, I have a block of things, you want unique allocations, I can do that for you. DHCP servers over the years have become, quite clever at doing these things. So I think it's well suited. You could use a number of things. There's also a suggestion that we use a SRMS. I don't know what that is, but you can use that. You can see that I'm really well versed in Spring, but it is a Spring thing. So there are alternatives. I think it's great to have a discussion. If you take it out of the configuration and put it into one of these protocols, I'll be happy. I'm not wedded to DHCP.
Just into a short comment. So you're keen on unique device ID, something like option 82. You don't really need locally defined SRGB, have it centrally on DHCP server, and just get right one. You don't need half configuration on device, half on DHCP server. Just make it ephemeral end-to-end.
So making it ephemeral is fine. sRGBs are typically going to be, unless you really want to move it, it'll probably be per OS or per release or whatever. It's not something that changes very often unless you have a specific reason for doing that. It's the SIDs that are the problem, not the sRGBs. Actually, that's a connection I have to make in the draft, that I say that the DHCP returns sRGB comma SID. I think you handle sRGBs as you do today. And if you stamp that out, if you have like 3 types of routers in your network and you have 3 sRGBs, it's not a huge thing to configure. Configuring individual SIDs and making sure they don't overlap or they don't clash is a bigger problem. That's the one I'm trying to solve.
Makes sense.
But again, everything's up for discussion. I'm going to now lean on the chair. I know we had a big discussion. Oh, please.
Yeah, Stefan Likowski, Orange. How do you see with the mapping between the SID with the algorithm? Is it part of your DHCP request, or will it be managed locally by the router?
Yes. What you said, I understood the words, but I didn't understand anything. So I have to think about that. I will consult with people who know, and we'll come up with an answer. But I think that whenever you have SIDs that you want to be global, so these are the flex algo SIDs?
Yeah, possibly flex algo, or you need to know at least locally on the router to which algorithm this SID is bound.
Yeah. So then it sort of goes back to the previous question that how do I get 2 or more SIDs?
Possibly, yeah.
So then, I think the request may be more than the prefix of the loopback of the router. So you might have other fields.
Okay.
So the type may have to be more than a type. You might say, I want a flex algo, but I have a subfield which is the actual algo. So yeah, all good questions, and I think we can extend that.
Okay. And regarding the manual, I would say manual allocation you were talking about, we are not really using manual things today because we have resource allocation tool. So you are doing a request to get already a seed from a tool which is completely automated the process, and then it goes to an automation which will provision the seed.
Which is fine.
Yeah, but I'm not telling this is a bad idea. It's just another way to do it.
Right. So we can standardize that using the HCP if people think that's the right thing, or we can do it with Lisp or SRMS or whatever. But I think it's good for us. I mean, if the Spring Working Group says node SIDs or these unique SIDs are important, I think it makes sense to at least have a recommendation. Maybe not a mandatory, you must implement this with DHCP, but here's a recommendation from the Spring Working Group of how to handle the unique requests.
Yeah. Agreed.
Thank you. Yeah. Yeah, go ahead.
Okay, Robin from Huawei. In fact, at the beginning of the segment routing, I already proposed that the SID should be allocated automatically, and also we propose a solution based on the PSAP and the BGP. We believe that the BGP and PSAP, not only the SID allocation, but also other functionality can also be used in our network. But I think if you use the DHCP, I think a little weird to me. I think first.
I like weird.
Yeah. The second one, I think when I propose the PSAP and the BGP, they propose this the challenge. They think the node CD especially, they think this always statically, need not always dynamically to be allocated. So I think they think this maybe not suitable for the dynamic, but maybe some of the binding SID or some this can be dynamically allocated. This is the second point. The third point, I think, because you use the DHCP, I also think this SRv6 or maybe some can use. But you know that the IPv6 address for the router, I mean, it's not the SID. How you use it? You also use the DHCP to allocate it. If you think the SID should be allocated dynamically by the DHCP server, I think the router's IPv6 address should also can be dynamically used by DHCP.
I completely agree, but I'm going to get short if I say that. The thing about IPv6 or any loopback address, people want to know what the mapping is from a loopback address to a device. And the idea that it's allocated by the DHCP server seems to scare them. But these SIDs don't have the same semantics. Well, I'll be careful how I say this, but typically they don't have the same semantics as an IP address. And the fact that this loopback belongs to this router, that sort of mapping is very important for operations. So I think this is well suited. I'm totally in agreement with you that IPv4, IPv6, loopback addresses, they should all be allocated by DHCP. I'm not going there. But I yield the rest of my time for those who, sorry, you have another question on this?
I just had a quick comment. Donald Eastlake from FutureWay. So I didn't quite understand why you have this unicast DHCP. I mean, DHCP is very clever at understanding how to have backup servers and so on and so forth. And if you're going to use DHCP, you should use DHCP, which at least multicast, if not broadcast or whatever.
Okay. I'm totally happy with that. When I actually learn what DHCP is, I will further answer that question. Having said that, I will just sort of have this plug. For those who are interested in the RMR use of segment routing, it's in the rest of the slides, but I'll skip that because we're way behind schedule. But thank you again for giving me a slot. And I will start a thread.
Thank you. Okay. Kind of give me a nudge at 10 minutes. Okay. Ron Bonica, and I'll try very hard to be as funny as Karidi. Let's go back here. We watched SRv6 develop for a while, and we talked closer to the mic like this. Okay. We watched SRv6 develop for a while, and we worked with customers. And there were parts of SRv6 we liked an awful lot, and parts that we felt needed to be improved upon. And our response was SRv6 Plus. In SRv6+, we make a distinction between topological instructions and service instructions. Let's see. Thank you. A topological instruction is executed on a segment ingress node. It causes an action, namely to forward a packet to the segment egress node. Some details: it overwrites the IPv6 destination address with the destination address of the egress node, and it forwards the packet to the egress node either through a specified link or through a least cost path. And it's encoded in an IPv6 routing header. A topological instruction in SRv6+ is the moral equivalent of an end instruction or an index instruction in SRv6. By contrast, a service instruction is executed on the segment egress node. So topological is executed on the segment ingress node, service on the segment egress node. And there are two kinds of service instructions. One is a per segment service instruction. It can be executed at the egress node of any segment. And typically it doesn't influence routing. An example is expose a packet to a firewall rule, expose a packet to a sampling rule. And we encode these in a destination options header that precedes the routing header. Another kind of service instruction is the per path service instruction. It's executed at the final segment egress node, at the path egress node. And typically, it influences the de-encapsulating a packet and demultiplexing its payload. For example, you get a packet, pop off the IPv6 header and all its extension headers, and forward the payload, say through a specific interface into a VPN. Or maybe get the payload, look up its destination address in a specific VPN routing instance, and forward it to the next hop you find in that routing table. We encode these in a destination options header that precedes the upper layer header. Now, why decouple topological service instructions from, topological instructions from service instructions? Well, the first is so you can use the most appropriate routing header. Routing headers are for encoding topological instructions. They're both intended to affect routing. That's why they're called routing headers. They both execute on the segment ingress node. The DOH preceding the RH is good for per segment service instructions. They can have scope beyond routing. For instance, they can carry OAM instructions, firewall instructions, and both are, and they're executed at the right place, at the segment egress node. DOH preceding the upper layer header are good for per path service instructions. They can have scope beyond the routing header, and they're executed at the right place. We also have a simplified SID semantic. A service instruction, simplified identifiers. Okay, a service instruction identifier identifies a service instruction. It appears in the DOH. It's not polluted with SID or IPv6 address semantics. A SID identifies a segment and the topological instruction that controls it. It appears in the RH, and it's not polluted with SII semantics or IPv6 address semantics. An IPv6 address identifies an interface, just the way it says it should in the IPv6 addressing architecture. It's not polluted with SII or SID semantics. An identifier identifies exactly one thing, and we don't pollute our identifiers with each other's semantics. And we never copy an identifier of one type into a field that's meant for something else. For instance, the SID that appears in the routing header is never copied to the IPv6 destination address header. There's a layer of indirection that mediates that. And I'm going to have to go back a second. Let's talk about that layer of indirection for a second. In a routing header, when we encounter a SID, that SID is an identifier into a SFIB, a SID forwarding information base. The SID forwarding information base has an IPv6 address that we copy into the IPv6 destination address, and it has a forwarding method, either forward through an interface or forward through a least cost path or whatever. Okay, so let's do a little cost benefit analysis. What is the cost of this architecture? Well, we have one more layer of indirection. When we encounter a SID in the routing header, we have to look in the SFIB to map that SID to an IPv6 address. This is required to maintain separation between the identifier types. However, it's not so bad. We've modeled this on our A6, and we find that even with that extra lookup, we can still forward at line speed. Another problem is we have one more routing header type. SRv6 defines the SRH, we define a CRH. They're both IPv6 routing headers, but our routing header type is simpler. It has fewer fields in it. It only has one field that does not also appear in the SRH. What are the benefits? Well, we have a simplified routing header. We have no need for the tag field, no need for TLVs. The SID identifies but does not contain an instruction. Therefore, the SID can be encoded in relatively few bits. Because the SID is short, the RH can be short, the routing header can be short, even when the SID contains a long list of segments. And there's no need to augment IPv6 OAM, because what appears in the IPv6 destination address is always an IPv6 address. Ping, traceroute, they all work because from the point of view of the IPv6 header, nothing has changed. More benefits is you can do some mix and match with routing headers and destination options. For instance, let's say that you want a packet to be demultiplexed at the endpoint, but you want it to travel the least cost path from ingress to egress. Well, all you need is the destination options header. You don't need a routing header at all. Let's say you want a packet to be traffic engineered from ingress to egress, but once it gets to the egress, you'd like standard RFC 8200 demultiplexing behavior. For instance, you'd like to use maybe a VXLAN header at the endpoint. Fine, use the routing header, omit the destination options header. Mix and match is an option. Another benefit, if you want to use the full set of IPv6 extension headers, you can. Right now, the segment routing header draft says the authentication header is undefined with the SRH. In this strategy, the authentication header works just fine. So you get overall simplicity. The existing draft covers the subject in relatively few pages. And here, now granted, this was done before, this was submitted on the same day that the microSID was submitted, so this doesn't take microSID into consideration. This compares the size of the SRH and the CRH with SID depths of various sizes. Let's take 8 as an example. In the CRH, a SID can be encoded as 16 or 32 bits. So for an 8 SIDs, we're comparing 136 bytes with 24 and 40. So there really is a significant savings. We have some implementations. We have a complete implementation on Linux that's both for the forwarding plane and the ISIS control plane. And we will have a Junos proof of concept very soon. And I see Ravi smiling. Anyhow, next steps. I would like to bring the overview draft Bonica Spring SRv6 Plus, to this group for a call for acceptance. And in 6-man, there are 3 other drafts. One that describes the CRH, the routing header, one that describes the destination option header at the end, that's the VPN desktop header, and one that describes the destination option header along early segments, that's segment point. Those will be presented in 6-man tomorrow. And at that point, I'll go to questions.
Okay, Robin Huawei. I want to know that if there are the control plane, the protocol extensions for this work.
I'm sorry, could you say that again?
I mean, so is there any control plane work for this?
Yes, there is control plane work. In fact, I think I have a list of, no, I don't have associated drafts. There was an ISIS extension that was presented in LSR. There are IDR extensions by Srihari in IDR. And Andrew Alliston has another IDR draft. The one that's missing is OSPF. That has to be done by the next IETF.
Okay. So my comments as follows. So first, in our opinion, because I think that's the purpose or the usage of the SRH or the SRv6 plus, I think maybe the similar. I think in philosophy, the information carried by the packet is equal, no matter it encapsulates the SRH or encapsulates the DOH plus RH. So I think from this point of view, I think if SRH is already deployed or already implemented, did we need another set of the huge of the effort to define the new set of the control plane and the forwarding plane?
The question is the incremental improvement of SRv6 plus over SRv6 sufficient to justify the work? And I'll leave that question for the working group to answer.
Okay, I think the second point is that for the shorter, this is the header from our point of view. If you compress that one, but you must to introduce the state in the forwarding plane because you must map the seed to some of the IPv6 address. I think
absolutely, that's what the SFIB is, but it is not per path state. It is per segment state, and given that that state is easy to propagate, it's not so bad. If you take a look at the ISIS draft, it's actually a subset of the SRH ISIS support.
I think this is a little different from the original design purpose for SR, that is the stateless. I just say that's one. The third point I want to say that for the shorter header, I know that's one. In fact, until now, we can already support the up to 10 layers of the SRv6 segment stack. From our point of view, I think this is not a big issue. So I think that's if you think that if you need to compress the SRH, I think we also need a method with a little press instead of a huge amount.
Okay, you're saying you support 10 SIDs in SRH?
Yeah.
That's a 168 byte header?
Yeah.
Okay. Jim.
Hey, Ron. Jim Gushar, FutureWay. I had a couple of comments. You mentioned about the no TLVs required. So, as you know, there's plenty of use cases where we may want to carry metadata with the packet. And obviously, right now, we would use the TLV in the SRH to do so. If you remove that, then you've got to carry it somewhere, right? And what concerns me is if you're going to carry that before the routing header, that could be very, very large before you even get to the routing header to be able to do any kind of forwarding operation. So that's something to consider.
If it's short, then you'd go with the destination before the routing header. If it's long, we're not trying to compete with NSH.
No, that's not my point. My point is that your slide said you don't need TLVs.
Right, we don't have it.
I think there are cases where you probably do unless you want to carry it before the routing header. And if you do that, then that introduces a problem in and of itself.
Yeah, if metadata is bigger than that, then it's time for the NSH.
Okay. The second comment I made is, and is this slide, it's a little bit misleading, but I think you said that yourself, because there are ways, very simple ways to compress the segment list. Just so happens that that hasn't been pursued up until this point. So the UCID is one. There's another actually simpler way of doing it that just got published as well. And you don't need any kind of mapping.
Neither of those were published at the time these slides were submitted.
So we need to compare it with that as well, assuming that that we can do that compression with a segment list, and it kind of overcomes that overhead.
That's for the next presentation. Tony
P. Juniper. Yes, I think this addresses two elephants in the room, which so far have been, painted translucent. One is that the 5G bandwidth is not free, right? So it's wonderful if you can build something that has 200 bytes headers and maybe even steam power it, but ultimately the amount of header you carry will determine the economics of your bandwidth. And not only of your bandwidth, but also we have a limited amount of power you can push into a rack and a limited amount of gates, right? So these will determine how dense you can deploy something. So it is an issue. It just determines your economic, how much of the bandwidth you carry, you charge the customer, and how much is just funky overheads you carry. So there's one consideration. The other consideration is this is decoupling the service from the transport, right? Which admittedly is not only how we scaled networks up, right? It's also something that tends to protect you when you have a really large networks and something seriously melts out, right? The layers prevent you from having one huge telephony switch that is cross-connecting the whole planet, and you have to reprogram on massive failures. So whether this solution will run on something else, I think this is just addressing those two big elephants in the room that so far have been just pretend not to exist. Thanks.
Thank you.
Hi, Ron. Gaurav Davra, LinkedIn. I'm speaking as an operator. The whole idea of actually having SRH is already implemented in 12 hardwares. It's already out there with customer deployments, with very large scale deployments. And then also, as you admittedly said, there is a microSID which is there, which will help with the efficiency of MTU. I don't see any reason of having another routing header. There isn't anything which is being added. In fact, I think there is a bit of a complexity being added over here by adding another header over multiple other headers we have. And even for service chaining, as you're saying, we need another header, which is the NSH. So
I'm very interested to hear technical objections. The objection that there is already another solution, I'd like to draw an analogy. Once a man had a horse, and he said his horse does everything that the automobile does already, so he doesn't need an automobile.
that's fine, but there is already that automobile already has multiple versions out there.
Okay. Tom.
Tom Herbert. So I'm wondering what your view is on the relationship between this and canonical segment routing. Is this intended to be complementary? Would it be a drop-in replacement for the network programming?
I'm sorry, I missed a word. Between this and?
Segment routing proper. So
SRMPLS.
So is it complementary? Is it intended to be a follow-on? How does it interact with all of the rest of the segment routing header?
It's complementary spelled both ways. It's complementary in that both should exist, both work for some group of customers. And it's complementary in that the SRv6 Plus architecture mimics the SRMPLS architecture in ways that SRv6 does not. SRv6 Plus mimics SRMPLS in that topological instructions are executed on the ingress node. It mimics it in many other ways that SRv6 diverges from it.
So is the implication of the plus mean this is somehow a superset?
No, it's complementary, with complement spelled both ways.
Okay.
Wim. Oh, Bob's next.
We'll get the lines after.
Hi, Bob Hinden. So I'm here with my 6-man co-chair hat. So ideally, I would like to hear clear feedback on this from the Spring Working Group as to whether this is going to progress, or you're interested, or you're not. It might be more importantly, you're not interested, so we don't have to repeat all these talks forever in 6-man too. So it'd be good if you could figure out how you're going to decide how to deal with this or not. I don't have a strong opinion one way or the other, but we would like to know. Thank you.
Okay, Wim.
Wim Hendricks from Nokia. So if you look to the current state of affairs with SRv6, I think there is multiple proposals. What has been done so far, you see that if you really implement with full flexibility, there is probably some performance penalties you will have in certain hardware elements if you want to run them at high speed, right? I think the question I have is, and this is mainly a question to the working group, not directly to yourself, is you will see that we need probably an optimization from what we have today with SRv6, right? Meaning SRH based, right? To something more optimal, which is more performant and doesn't have those drawbacks potentially in certain hardware element. And the question to the working group will be, do we want to adopt multiple of these options, or do we want to have a discussion, okay, which one is the most preferred, more optimal and more hardware friendly, rather than trying to boil the ocean and come up with multiple alternatives? Because if you look to what you're proposing here, there is today even a working group document. It's MPLS based, but it uses, so it's segment routing MPLS over UDP, which is using a v6 destination address, which is actually doing exactly what you do here. It is using MPLS encoding, but it uses 32-bit, which is an MPLS label, which is actually doing more or less the same thing what you have here. And the question which I have to the working group is mainly, do we want to adopt like all of these different options? Because we'll end up implementing all of them if we have multiple options, and I don't think we do an industry a favor, because we will end up competing into the market and we'll have to implement them all, and it will take a longer time to actually adopt that towards the industry. So it's more a working group type of question compared to...
It brings up an interesting question.
Yes.
There are three ways we can go. We can have a shootout among options. We can try to merge options, or we can let all options grow and let the market decide.
Right. So this is actually a question to the working group, yes.
Yeah.
I think
that is exactly the last call question.
Yes, yeah. And even working group adoption question, I think the question is actually, what does the working group wants to get out of this? I do believe that there is an optimization required from what we have today. And I would be of the opinion to basically try to come up with one proposal on how to do that optimization, rather than trying to boil the ocean and let the market decide.
Okay, Andrew.
Yeah, I'll say up front, I was a co-author of this, but I'm going to take that hat off for a second and speak as an operator. When we got involved in this draft, we did so because we looked at the network that we run today, and SRH with the overheads, when we did the calculations on our packets per second rates and the overheads and the numbers of SIDs we were stacking and everything else, the overheads were untenable. Keep in mind, I run a very large network in a place where bandwidth is not cheap. You know, there are places where I'm not getting bandwidth at 20 cents a meg, I'm paying $15 a meg. That overhead starts having real impact at points. And so when we started looking at this, I just wanted to say that that cost of that overhead has a fundamental impact. And we talk about operators and operator positions within the working group to, as the previous speaker was talking about, from my perspective as an operator, I could not justify deployment of SRH today because of the overhead. And when I look at the other things with regards to this draft, I know exactly how with this draft I can stitch between L1 and L2 segments. I know that this draft is not going to inflate my IGP, which could happen potentially with the microSID drafts. There are a number of other issues, but I just wanted to say that as an operator, that's why we got involved in this, because we looked at it, and looking at the market that I operate in and the very large network that we operate across all of those countries, I could not work with SRH in its current form, and I still won't because of the overhead.
Two things.
Okay.
First, we cut the line before, so we cut the line before you, and also for Dirk, we cut the line. Yes, but it was after we cut the line. And Robin,
Okay.
please,
Okay,
be brief and short.
Okay, sure. I think I agree that's the operator's opinion. So my opinion that is we can use the method with a little press. So that's the first. The second one, I think this regarding the payload efficiency issue. I think there's the possible way, like the binding seed or some other can solve this one. And also, if we think this is the payload efficiency, but I think for 5 years ago, they argued the 10 layers of the label had the issue. But we retrieve back the IPv6, we should not use the 16 bytes as the address, or maybe we need not the extension header. But we must agree the requirement.
So I just have comments about the name of the solution. So based on my understanding about this draft, I think it's different from the current SRv6. So I think it's better to have another name for this solution.
I'm sorry, I didn't understand the last thing you said.
So, yeah, maybe it's better to have another name for this.
Oh, I can call it anything you like. Yeah.
David Melman from Marvell. I totally identify with the issue of the size of the SID list, and Marvell, the silicon vendor, we certainly see the pain point as well in supporting a large SID list. But I'm wondering whether the approach of doing SR MPLS over IP isn't already an acceptable solution for doing sort of the compressing the SID list using MPLS labels as SIDs.
Well, that's an argument in that case for getting rid of both SRv6 and SRv6+. We see that there are some operators, one who just stood up, who's going to make his case for needing an IPv6. Okay, I'm going to read his mind. He's going to make his case for IPv6, as is exactly the case that everyone who's spoken in favor of SRv6+. They need an IPv6 based data plane.
Right, well, SR MPLS over IP supports an IPv6 data plane, correct, in terms of the forwarding?
Well, more than that.
Okay, so you ask for adoption. We think it's too early to adopt either.
Okay, could I ask at least for the reviews to get it on the path, or at least people? What's that?
Yeah, but he went on the line after we cut the line. So to be fair, the rule is the same for everyone.
Okay, so what would the next steps be?
So it's too early for adoption of this new work. Same thing for microseed or any other extension for changing. Just to remind the working group, we already have a solution for the IPv6 data plane. It's called SRv6 SRH. Both 6man and Spring have been working for 5 years on it. So we are not starting from scratch. We do have a solution. So if it's not good enough or something is missing, we need to understand exactly what the issue is. So is it specific to a specific deployment, needing a lot of seeds? So coming back to your figure, what is the limit? What's the number of seeds you need? Same questions with implementation. What exactly are the limits or the constraints? Is it specific to one implementation, or is the issue large for all the industry? So we need to understand the problem compared to what we have, both SRv6 and SR MPLS, and then we can discuss if we agree that there is a problem and we agree on the constraint. Then we can discuss.
So would ask then for people who see a need for something else to speak up on the list?
Yes, but they need to understand, to specify, for example, if this is a vendor, what is their limitation? So what was the problem? Same thing for deployment. What is the requirement in terms of number of seed? Because in the end, we'll have to find figures. What is the right value for the seed? For SR MPLS, it was easy. We took the size of the MPLS seed, which is 20 bits. For SIV6, we choose IPv6 address, which is 128. if we define a new seed on our own, we have to choose the value, the size, you know better.
Mhm.
So we have to know the constraints.
Okay, so that sounds like not so much a mandate from the chair to go away, but let's bring the conversation to the list.
Yes, we need to understand what is the problem compared to SRv6, SRH that we have been working on for 5 years on SRMPLS, on SRMPLS in UDP. So we have existing solutions.
Okay.
Alberto Rotana, Routing AD. I just want to make sure that I understand the direction. I don't have a comment for Ron. I just want to make sure that I understand the direction that you're setting. What I think you said is that for now, the working group has a solution, but we want to understand if there are holes, whatever, something needs to be done, which sounds like you're leaving the door open to say we could have a different solution. Is that, I mean, after proper discussion and everything else?
I think that's right. I think the challenge is we probably don't want N improvements over time, right? It's fine for us to look at technology and say, hey, this is not right. But we need to understand what the constraints we want to engineer within are. Like, so what is the set of problems we're going to solve? What are the constraints on it? And then let's look at the solutions that we have out there and say, is the advantage of them significant enough that they're worth progressing, like adding it into the industry? And if they are, then we progress them. If not, we should. But what we don't want, I think Bruno and I discussed yesterday, we don't want, okay, like here's SRv6 plus, and then here's SRv6 plus plus, and here's SRv6 plus plus plus.
That works perfectly for me. I just want to point out that I believe that 6-man already working group has called and sent to the ASG the SRH document. So if we are going to think about it, maybe we need to let Suresh, who's now responsible for that draft, know that we're going to think about it a little bit. Doesn't mean stop completely. It means, as you said, we might think about it for a little bit and then go back and say, yes, keep going, or something. I don't know. Again, that's why I want to clarify what we are thinking as a working group.
I think that's an interesting position, right? For us to say that, we need to say the current SRv6 isn't actually useful, right? And I think that we're not necessarily, it didn't sound like you were saying entirely that you think the existing thing is not useful. I think you're pointing out limitations and potential improvements on top of it.
Well, I tried very hard to be neutral towards existing SRv6. The one thing that I'm most concerned about is that because we've gotten where we are now ossified, and that we will obstruct any more progress. I want an assurance we're not there. With that assurance, I'm fine with SRH progressing.
Hi, Suresh Krishnan, talking as Int AD for 6-man. So I'll tell you what my working assumption is, okay? So my assumption is I'm sending SRv6 forward, unless I hear screaming from the Spring side. So that's my working assumption. I finished my AD eval, the authors are fixing the stuff, and it's going to go into IETF last call. So that's how I see it. And we also gated any SRv6 related work in 6-man until the SRH was done. Okay, so there's a bunch of drafts that's going to get some airtime tomorrow, talking about extensions to this. Okay, so maybe that's something we can play with, but I really would be worried about pulling the plug on this at this time. Okay, so unless it's some catastrophic event telling me this is we totally screwed up, blah blah blah, I'm sending this forward as the AD for that. The second thing is, Bob kind of alluded to this, right? We are kind of looking for guidance from Spring to see how SRv6 plus related work is going to happen in 6-man. So we are expecting Spring to say hey, we are considering this, so we say, can we do headers or options in 6-man related to SRv6 plus? So it's similar, we are treating SR and SRv6 plus the same way. So Spring tells us this is architecture, we are considering it, now do the things for that, right? I had this chat with Ron as well, right? So the idea is so the SRv6 stuff, the SRH is going forward, unless something drastically changes. And all the add-on work for SRv6 is going to be considered at some point, right? We don't know when. We're just doing lightning talks at this point because we gated this for 2 years. So that's kind of my working assumption. So if you think some of it's off, kind of talk to me and the 6-man chairs as well. So I know you guys had a good conversation on how we distribute the work between 6-man and Spring, but I think if something has changed, we would like to know. Okay.
Hi, I'm Daniel Voyer from Bell Canada, and I'm going to be presenting the SRv6 microSID on behalf of a few authors, to say the least. How's this thing working? Okay, so the SRv6 microSID concept is a new network programming SID behavior. It follows the normal N that are already defined. It's seamlessly combined with the other SID behavior. It's fully integrated with the network programming and the SRH, and it offers incrementals for deployment in the SRv6 network. It also enables the SRv6 scaling for massive network with optimized MTU. So how does this thing work? Oops. So the macronode SID behavior, it's another variant of the endpoint behavior. It's an 80-bit argument that contains the next macroSID in the macroSID carrier. So basically, upon receiving a packet whose IPv6 destination address is a local macronode SID, the node will perform the following. The 16-bit following the active macroSID with inside the destination address, if it's set to 0, then it will shift the 48 to 127 bit to by 16 bit to the left, and then it will set the last 16 bit to 0. Then we'll forward. Otherwise, we'll execute the end pseudocode, and that's pretty much what we have to understand from the microSID. The end pseudocode is defined in the section 4.1 of the network programming draft. So, few benefits. Just like any other SRv6 endpoint behavior, it's a new instruction for the SRv6 network programming. It's SRH compliant. There's no new IPv6 extension required. It has some efficiency in terms of MTU usage. It's scalable for the SR policies with 18 source routing waypoint in a 40-byte SRH. Sorry. The version that we just published last Monday, the little difference is the last bullet here. We made it any IPv6 block available to an operator can be used instead of the ULE. That's the difference between the version 0 and the version 1. Other benefits, it's hardware friendly. So for us, a lot of operator, the one from my previous slides, it's kind of key that that we can be in control of the SRv6 deployment on the legacy platform. As an example, the Jericho one and other legacy platform that exist. So if we have already these platform in the field, now with this option in this proposal, we can keep running SRv6 as deployment. There's no control, it's pretty much control friendly. There's no mapping table. There's no routing extension required. That's it. Is it 5 minutes?
Before we come to questions, I think most of the comments on the compressed header applies to your proposal. So first is, what is the problem exactly with SRH or SRMPLS? We need to define it. So there are a number of claims every time, so it's shorter, hardware friendly, but SRH was supposed to work, and also it's for something for SRMPLS. So we need to understand exactly what is the problem.
So the SRH was supposed, it is working on many platforms. We have a couple, we have a draft that shows some deployment, but it's more on the legacy platform. Anyone that has some Jericho ones in their networks, unless there's something specific with some vendor or some other legacy platform, will be able to run SRv6 with those proposals.
Yeah, but we knew that when we defined SRH, we knew the size of SRH. We knew that those legacy platforms would not support it. Mm-hmm. So what's new?
So just Darren Dukes, Cisco Systems. Just wanted to point out that this still uses the SRH as it's defined. It doesn't change that. The SRH as it moves to RFC can carry micro-SIDs. They're just a SID like any other SID. The SRH draft also says that additional SIDs can be defined in the future, and it gives a way of defining those SIDs. This is just another SID. So it's normal operation for SRv6.
Yes, it reuses SRH. From that slide, it does change the forwarding on IPv6 packet, native IPv6 packet, because
No, just like so, like any other.
You don't have SRH here.
Except for the other part that says else execute the end pseudocode. The end pseudocode describes how the SRH is processed, and I believe there's a reference in the draft to the network programming draft as well. So the SRH is used by a micro-SID if it's present.
Reusing the SRH does not say that doesn't mean that we don't change anything from IPv6 standpoint. So if we work on that, we need to work with 6man to see if it's fine for IPv6.
And this is just another SID. Maybe I'm not following the question, but
Maybe we can take.
It's as any other SID. You receive it, you process it, you do the action that the SID says to take, and go to the next SID, which is carried in the arguments.
Okay, Cheng from Huawei. And first of all, I think it is the right direction to enhance the SRH-based SRv6, because what Huawei has done in the same way. But I don't think this solution is flexible enough, because each time when you introduce a new SID, and you have to make twice implementation for the normal SID and the USID, right? And then all the SIDs would introduce the roots, which means the roots are needed for each SID, including the USID node and USID such as adjacency USID. Yep. So my point is, it only supports the loose TE right now, and if we want to support like street TE, then new USIDs are needed, right? And the second point is, I saw the prefix is changed from 16 to 32 bits. Does that mean people cannot afford the 16-bit prefix because it would burn all the addresses in that block, right? Since the address shifting. And the last one is, I don't think the 80-bit argument in the DA is correct, because because maybe you should use another name. It is no argument. And finally, I don't think it's supposed to reduce mode, because when you use the reduce mode, and the pass information will be lost. And by the way, Huawei has posted a draft to define a new solution. Yep.
Do you expect I answer all your points, or we can just?
It's okay. It's okay.
Okay. No, if we can take it offline and review all your points.
Yeah, it's good. It's better to do it offline because the time is limited. Yeah.
Thanks.
Oh, can I just comment on one? Oh, okay.
There's a long queue. Go ahead.
Steph.
Hi, Andrew here from. I wanted to just say, I was listening to what you were saying about it just being another SID type. It's not, and here's why. If this is just another SID type, I'm not having to distribute it in my IGP for every node that I want to steer through in a way that is going to end up in my standard V6 fib, which when you're running low fib devices on the edge, you are going to dramatically increase the size of my IGP, which could have consequences, serious cost consequences on the IGP when you're adding more and more and more, because these are V6 addresses from that perspective. And we spoke, I was listening earlier when they're talking about legacy hardware, and support this because it's nice on legacy hardware because it doesn't have to do label processing. But look at the counter argument to this. The legacy hardware is slow fib, small devices, and the very thing where you're helping on the one you're shooting it in the foot on the other because of the increase in the fib size. And that to me is a really, really major concern. Aside from the address space, you've got issues with the address space, but that inflation of the IGP that this will cause, from the way I read it, is a massive problem. And that's not just another SID, that's an address because it's being propagated straight into my normal V6 fib.
There's a couple points in what you mentioned. The IGP scale, I think it's not correct. I think there's techniques to address that. And the second point that you mentioned, the small legacy things, I think we should probably go offline to really go in deep of what you mean. I'll be pleasure to do so after this workshop.
Yeah, sorry, if I can just add one other thing that I forgot as I was walking away.
Yeah.
In this, in order to reduce fibs normally, we use a lot of L1, L2 areas. In a V4 world, we can stitch, labeled unicast. I can do the same with SR, MPLS, etc. Can you explain to me with this, because I couldn't get it, I really tried, how I'm going to do that kind of L1, L2 stitching while preserving the ability to steer across both without flooding my L2 area, because I couldn't understand how to do that. I really looked and I couldn't grasp it in the context of this, so maybe I'm missing something.
Excellent. We'll take it offline because I think we're going to stand here all the way for 12. But yes, there's techniques for that. I'll be a pleasure to discuss with you.
Just had one quick point. Sorry, that Ron, as Cameron as a Cisco Systems, Dan said there are techniques. You do not necessarily have to basically impact your IGP scale. There are techniques where you can advertise one prefix that covers both. And by the way, when you're saying we're advertising SID, we are not advertising SID in FIB. It is a locator, which is the IPv6 prefix. Well, we can continue more on offline.
Yeah. Steph, go ahead.
Stefan Kowski from Orange. The question is not for you. It's for the chairs.
Okay.
Because I don't have any opinion on what would be the good solution today.
Okay.
So I completely agree with your approach that we need a kind of problem statement. What kind of problem do we need to have to solve today? But what kind of information are we really looking for to know what is the problem? I think what we need is what are the hardware limitations today? And even if it's not really a limitation, what is the extra cost on the ASIC production to get SRH working properly with all the use cases that we need at line rate? And do you really expect the vendor to disclose this? Because for SRMPLS, we have never been able to get this information, while today we still have some hardware issues with existing platforms.
That's a good question. It's clear that if everyone says that they can do everything,
that's not true.
Yes, but if they do say that, there is no problem in terms of hardware, and we cannot work on solution limiting the issue in terms of hardware.
Yeah, but I'm really worried that we will never be able to know that there is a problem to solve.
So do you have a suggestion?
Unfortunately not. We can just get the information today that SRMP, we are not able to do everything that we want today with existing platform with SRMPLS. So we can foresee that with SRH, which is using bigger length of SID, we will have bigger problems.
That's for sure.
But yeah, that's just a statement. We are not sure because we are not able to get the right information.
The issue is, do we have issues with 10% of deployments or 90% of deployments? And same thing, do we have issue with 10% of hardware or 90% of hardware? We have to know some kind of information because we can't accept 20 solutions.
So what's your plan? Do you want to do a kind of anonymous survey to the vendors?
I think it's a good point, right? But it's the same discussion we had about like, how long does the SID stack look in SRR and PLS at the start, right? Like, I think when I was at an operator that was looking at adjacency SID stacking, and we had debates about this. I think we have to rely on the working group to bring anecdote data if it's not definitive data, right? Like this is the some indicative data about what the constraints are, and we know it's not going to be perfect. But the problem is if we say, okay, there's no data at all, then like at what point do we have a problem? Like one solution could be here, say, we'll make it look as much like SRMPLS as possible because we know what the constraints of SRMPLS are and there's these folks deploying it. We probably want a bit more of a guidance than that to be able to figure out what the right things. But the point's completely valid, and that's the challenge we have here, right? It's very easy to stand up and say, hey, this thing isn't optimal, but how important is it not being optimal?
Okay. Short comment on the previous question. So there are two RFCs that define MSD, and it clearly state, have your vendor communicating to machine-to-machine interface what your platform supports, so it could be advertised in IGPs and PCAP BGP, so your PC can actually compute paths properly. If you're a customer operator, demand your vendor to expose its limitations.
A good comment. There is also a draft, I think, proposing to advertise in MSD the capability for each router to be able to push many IPv6 seed. So apparently there is a willing to advertise such hardware value in the IGP, in which case it will be public, in which case we can send it to the MPLS working group, to the MPLS or as Spring working group.
Ron Bonica, Juniper Networks. One of the advantages of IPv6-based segment routing over MPLS-based is you retain a trace of where the packet has been. You don't pop every label off along the way. In microSID, is there a way to retain a trace of where the packet has been, and what is the cost of that in terms of encapsulation size?
Yes, in the network programming draft, I think there's a section, is it the 4.13 that describes like if you want to do like a trace route or something like that when you have, or no
okay, what is the cost of that?
Well, common as a Cisco system, if you don't do the reduced version, then it's in SRH. Although you can have a shift and forward and updated destination, but SRH still have the actual destination.
Okay, so it's 128 bytes then. The next question is, in the draft, in the example in the draft, the only thing that the SRH carries is an NDT4. That has nothing to do with routing. It's actually a destination option. Why is that in a routing header, given that there's no routing to be done by that routing header?
It's a good question. Maybe you can write it in the mailing list, and I'll take care to reply to it.
Okay.
We'll cut the line, and we have a comment on Miteco. Dark.
Oh, go ahead.
Dark. We can't hear you.
Garudavra, LinkedIn. Speaking as an operator, I think this is a step in the right direction, especially all the simplifications which come with SRH. Even though, and also this handles the MTU efficiency, which is what Dan was also referring to, is the for the legacy hardware. So I think this is applicable at least in our scenarios.
Dirk, I'm sorry, we couldn't hear you. If you can send your question on Jabber, maybe. Sorry.
Jen Linkov, I'd just like to mention that the comments we made regarding the network programming draft actually applies here. I'm glad to see that ULA usage was removed from the draft, but I still think we need to clarify in the draft what the address space you need, what's the size of it, and because currently it's unclear. You said any address space allocated to ISP, so it could be /32/48, can it be /64? So I think more analysis need on address space and where that address space is coming from. Probably, as Lorenzo mentioned, we might request a special block from IANA, which is not publicly routable and could be used by any network. I'm basically concerned about using too much of address space without proper justification.
So we'll clarify that in upcoming versions, but the short answer is yes, it does apply to many type of prefixes. So obviously the shorter it is, the less you said you're going to have, but we'll clarify that.
Shraddha Hegde, Juniper. So
hi.
My question is with respect to the n.dt4 SID that appears in an example in a separate SRH in the draft.
Oh.
So this also comes out of the locator space. So can it also be a microSID? So it appears as part of microSID rather than a separate SID in the SRH?
Can you? Did you get that?
Yeah. That will be future work in the draft.
Okay.
Robin Huawei. In fact, I insist that if we want to solve this such issue, has this the concern, I think that's with little press. I think that's for the SMPRs, they already use the binding seed solution. I think this is the mature. I think this is the first one. The second one, even use the SRH, this compression, we propose one draft. That is compatible with the SRH without the control plane extension. I hope that you can refer to this one. Okay, thanks.
Thanks.
It's Peter from Cisco. So I just want to make a comment on the Andrew's comment about the IGB exploitation with the microSID. There's none. There's no difference in advertising the microSID and the regular SID. If you have any concern, I would like to know. We can take it offline and talk after the meeting.
Ron Bonica, Juniper. A minute ago, we said that we could put the NDT4 in the IPv6 address in the microSID along with all the other SIDs. If that's the case, what do we need an SRH for?
Outside the scope of this draft, maybe I can.
That brings another question that is probably for the AD. Given the conversation we've had around the interaction between microSIDs and the network programming draft and CRHs.
Well, actually, sorry, Ron, if I can answer your first question. I think we already said that you can put multiple microsids in an SR header.
Okay, if you need to go deeper than 8.
Yeah, add more. If you want to,
okay,
if you want to maintain the state,
actually
if you want to maintain the state, put in the SR header. The SR header draft and definition still exists, and this is compatible with it.
So
still for use.
In cases where you need fewer than 7 SIDs, you wouldn't need any extension.
Well, right now, the SR header draft says that an SR source node may or may not add an SR header, and that's already in the draft, and that's something that we've, that's been in there for a very long time. It applies to this microSID, it applies to every SID. So there's no, I don't think there's any discussion to be had there.
But we could take it in the mailing list to formally provide an answer as well.
And then the rest of my comment is probably addressed to Alvaro. Given that we've discovered these new interactions between microSID and other SIDs and other things, it kind of makes me wonder how far the network programming draft is from being mature. It may be a working group draft, but far from mature.
So far, microSID has not been adopted. So it's a 001 presentation. So far, there is no interaction with the working document.
You willing, if you're willing to contribute in the microSID, who can discuss? Nika, anything else?
Now let's move on to the next presentation. Thank you, Dan.
My name is Shraddha. I'm going to talk about TTL procedures draft on behalf of my co-authors. So since last presentation, we have new co-authors contributing to the draft. So, a short background on what this draft is all about. So the MPLS traceroute procedures uses TTL expiry mechanisms to visit every node. So it needs some kind of a special handling for PHP cases, and this draft is talking about the solution for penultimate hop nodes for traceroute. So in this version, there is an update on how the TTL procedures need to be handled for binding SIDs. And the next few slides talk about how it is done for binding SID. So in short, there is no big difference from how it is being done today for other hierarchical LSP cases from 8029. So it's just a clarification for binding, how it can be done for binding SIDs, because from last presentation we had questions, that how this is done for binding SIDs. So we see here a set of routers R1 to R6, and there's a path set up using two labels, 1006 and 8001. The 8001 is a binding SID that expands into 1004, 1005. So that's the SR path that's been built. So if you have to do a traceroute procedure for this, so there are two different modes in which this can be done, a uniform mode and a short pipe mode. Uniform mode would visit the nodes which is concealed by this binding SID, and the short pipe mode would take a hop from the node that advertised binding SID and would not reveal the nodes that are represented by that binding SID. So in the step one, if we see here, the R1 would send two SIDs, that is 1006 and 8001. So that would go with the top one would go with a TTL of 1, and then R2 would it would visit R2, and then it would look at the 8001 and inform a FEC stack change as defined in RFC 8029. And then the FEC stack change would have those two FECs for 1004 and 1005 in uniform mode. So the next step, R1 would increment the TTL and send it to R2. So the TTL would, on R2, if you look at step 2, it comes in with 2, and then it TTL on 8001 gets decremented to 1, which gets copied onto the new labels that got pushed, which is 1004 and 1005. And the FEC validation for 1004 would happen on R3 and R4, which is very similar to what's already been discussed. There's no change. And as and when the packet visits every node, the TTL if you see binding SID keeps increasing, which gets copied onto both the labels that got pushed because of the binding SID. And that's step 3. The 1004 get popped, and that gets the TTL gets copied onto 1005. And when 1005 gets popped in the step 4, it says it's a PHP, and then so the bottom label on R1 gets incremented with 1. So you receive a packet on R5 with 1006 with a TTL of 1, and then the procedure continues. For a short pipe mode, you don't really want to reveal the network which is concealed by this binding SID, so you don't copy the binding SID's TTL onto the other labels. So you continue with the TTL of 255. So the trace route would not visit R3, R4, and R5, and the packet arrives at R5, and then it directly looks at 1006, and then that's how the trace route would continue. So this is an MPLS working group, so we will send a request to MPLS working group to adopt this document. Questions and comments?
Zafar from Cisco Systems. I have just one comment. There's nothing new, right? This is known. This is how it is. Do we need to document this?
So basically, it seems like this is how it is to be done is not very clear from the existing documents, and that's the comment we got, that it needs clarifications. So that's what is being. So there are two things: the PHP stuff that needs a change, and there is this clarification, which is nothing new, but an explanation of how it is to be done.
No, that's fine. Yeah, I just want to point out this. You receive comment from customers that needs clarification?
Yeah, yes. So actually, this was a comment from last time's presentation. So that's why the draft got updated. So basically, this document mostly should address the TTL procedures, things that are not clear from the existing documents.
Lou Berger. I guess this might be a comment more for the MPLS working group, since that's where the document is. Something that would be really worthwhile to clarify, and maybe it's a little too big a scope for this document, but it'd be good if there was clarification on what SRTE is. You reference a document that doesn't mention TE at all as the defining document of SRTE. I think working that in the MPLS working group would be great, but we need a definition of it if we're going to use that term.
Yeah, I think
actually, to the chairs, you did reference an SRTE policy document, and I looked, and there's no SRTE, there's no TE mentioned in that document as well. I don't mind using the term, but let's define it. And I think if you want to do it in MPLS, that's awesome.
Yeah, sure.
Yeah, since they did do MPLS TE.
Thank you. Do I have the next presentation?
So next is Zafar. I believe so in the agenda. It's going to be clear that we are not going to do the whole agenda. We had a long discussion on network programming, which is an important working document, so I think it was important. And a long discussion on do we need to do something to reduce the size of the SRv6 seed, which I think was important also. So we have to apologize to Zafar, Shradha, Rakesh, and Zibo, because apparently there is no way we'll be able to present many items. Zafar, sorry.
Great, thanks. So this is the SRv6 ONM draft that I'm presenting on behalf of my co-authors. This is next page, please. Next. Yeah, so basically this work started 2 years back. This has been reviewed and presented to 6-man and Spring Working Group multiple times. There has been revision and comments on the mailing list, and all these comments have been addressed. There was some offline discussion as well, many offline discussion as well on the draft. So from that, this draft has been very stable. There are deployments. There is a draft that describe all the deployments. It's a public information. The deployment at SoftBank, China Telecom, their deployment Elite Network, and their additional deployment in preparation. And this draft is part of the deployment. From implementation side, we have at least 10 platforms shipping this information. There are other known implementations, and public information is publicly available at the draft mentioned here. And there was interoperability done at EANTC back in March, and then it was showcased in April at MPLS World Congress. We have also done some additional private interoperability among multiple vendors. And some of the details are in that draft that I mentioned for deployment status. For draft summary, and it basically defines OBIT flags already are defined in SRH. So it defines one of the flags as the OBIT, it defines the usage that flag, and it defines 2 ONM sets, n.op, which is for you receive a packet, and then you have n.op set, you punt it, and when the n.otp, which is you receive a packet, which time is stamped and punted. It then defines usage of these toolkit for ping and traceroute, and it also extends the path monitoring, which is in RFC 8403 for SRv6 network. The main point that I want to discuss here is that where the chairs would like to proceed this draft. We can take 2 positions. One position is that the flags are already defined in SRv6 network programming, so other working group can define a flag in its usage. And and so Spring can define that, for example, and with obviously review done at 6 men, all the expert reviews done at 6 men. The other option would be that this draft actually get proceeded at 6 men. But at the moment at this IETF, we would really like the working group adoption. We don't have any preference whether it happens here in 6 men or it happens here in Spring or it happens 6 men. But there has been multiple implementation and deployment, and this draft has been there for long, and I presented multiple times. It's been there for 2 years, actively discussed. So it's time for the adoption for this draft.
So we are kind of waiting for the SRH work to finish on this table. So now it's moving to ISG. Regarding whether it's to be done in Spring on 6 men, we don't care. We don't have an opinion. By default, it's an IPv6 extension, so 6 men has a priority.
Okay.
But so we'll discuss with 6 men chairs.
That's fine.
I don't have any preference.
Yeah. So this is on agenda for 6 men. So I ask the adoption in 6 men, and you for this draft.
Yes, if you want to take it to 6 men, it's excellent.
Thank you. Any questions, comments? Okay, thank you.
I think given that we only have 4 minutes, we won't try and ask somebody to squeeze their presentation that was 10 into 4. So nothing else then. I would propose closes Spring for this meeting. Rakesh says that he can cover in 4 minutes. There we go.
Okay. So we still have 4 minutes to go. We have a short presentation from Rakesh.
Good morning, everyone. My name is Rakesh Gandhi, and I'm presenting the IOAM for SRMPLS data plane on behalf of the authors and contributors listed. So requirements and scope, procedures, and next steps. So basically, this is carrying the IOAM data fields with the SRMPLS and encapsulation. What that means is the OAM information carried by the data traffic. So we are using the data fields defined in the IPPM working group document. So far, we're looking at the end-to-end IOM, and we will add the hop-by-hop IOM in future. So the encapsulation has indicator label as well as the data fields defined in the IPPM working group document. So basically, encapsulation node inserts the indicator label as well as the IOM data field in the header, and the decap node forwards the packet but takes a timestamp copy of it for IOM processing. And it also removes the indicator label as well as the data field. So there are 3 methods that's possible for the indicator label allocation. The first one is the INI allocation. There can be a global label that's allocated by a controller or a signaling mechanism. So we can take the feedback from the working group on which method to go with. There is some implication on hashing as well. The couple of them listed here. Definitely, if the indicator label has the end of stack bit set, then the 04 or 06, the IP protocol, the IP hashing looks for that. So that may not work. As well as if the hashing is using the labels, then now it may include the indicator label as well. So next steps, we will add some more details on the ECMP hashing. We can also include the hop-by-hop IOM if there is interest for that work. We welcome your comments and suggestions, and we are seeking for working group adoption. Thank you.
One question. Have you presented to MPLS working group?
Sorry?
Have you presented to MPLS working group?
Yeah, I presented this on Monday.
Okay. A priori, it's a bit heavy on the MPLS extension, so probably it should be in MPLS working group, but we can discuss with MPLS chair.
Yes, the feedback was that if you're going with the method 1, which requires the INI allocation for special purpose label, and that is in the MPLS working group. So Loa mentioned that this can go to MPLS working group.
So do you want to figure out which option you want to pick before, or otherwise it's by default it's probably going to be MPLS working group?
Yeah, so I think we would prefer the method 1, but if working group has any feedback, then we can look at the option 2 or 3.
Okay, excellent.
Okay.
One comment, Jeff?
I believe it's covered by some IP. I'll contact Ericsson to review this. But we had discussion before, the same pattern. It will cover exactly that use case.
Okay,
thank you, Jeff.
So I'll let Ericsson lawyers to comment on this.
Okay, yeah, thanks.
Chung from Huawei, I'd like to know why should we need this work? Because I think IOM costs a lot. And if you want to do IOM in MPLS and postcard-based telemetry would be better, much better. Thank you.
Okay, yeah, we can talk offline.
Okay, thank you. We're done.
Yeah, thank you.
We are still operating our own.